Have you ever looked up at the night sky and wondered what it would be like to stand on another planet? It's a fantastic thought, a dream of adventure that has captivated humans for centuries. We imagine ourselves planting a flag on the red soil of Mars, or floating among the beautiful rings of Saturn. But what if we actually tried it? What if, for just a moment, we stepped out of our spaceship onto the surface of each world in our solar system? This isn't a journey of discovery and triumph, it's a cosmic tour of all the spectacular ways the universe can end you. Our solar system is filled with beautiful, majestic, and unbelievably hostile places that are not designed for human life in any way. This grand tour will take us from the blistering heat of the inner planets to the absolute bone-chilling cold of the outer reaches. We will explore what makes each planet uniquely deadly. Is it the crushing atmosphere, the poisonous air, the supersonic winds that could tear a person apart, or perhaps the simple, unforgiving vacuum of space combined with extreme temperatures? We will look at the science behind why you can't just take a casual stroll on Venus or go for a quick dip in the methane oceans that might exist deep inside Uranus. This is a survival guide where survival is not an option, but understanding the failure is the entire point. We will break down the demise of our hypothetical and very unlucky space explorer on each planet, from Mercury to Pluto. For each world, we will describe the environment in simple terms, explaining the scientific reasons behind its lethality. We'll calculate, with a grim sense of curiosity, just how long you might last, seconds, minutes, or perhaps a little longer if you're lucky. We'll also highlight a single, interesting fact about each planet's particular brand of danger, that one special feature that makes it stand out in our solar system's Hall of Horrors. It's a morbidly fun thought experiment that helps us appreciate the delicate, life-sustaining bubble we call Earth. So buckle up your theoretical seatbelt and prepare for a voyage unlike any other. We are about to embark on a journey that will test the limits of human endurance in the most extreme ways imaginable. This isn't about finding a new home among the stars. It's about appreciating the one we have by seeing just how inhospitable the neighborhood truly is. From crushing pressures to fatal radiation and temperatures that swing between melting lead and freezing air solid, get ready to discover all the ways you could die on every planet. Our cosmic journey into oblivion starts now, and our first stop is the tiny, sun-scorched world of Mercury. Our first stop is Mercury, the little planet that hugs the sun. It has no real atmosphere to speak of. This means there's nothing to breathe, nothing to block the sun's harsh radiation, and nothing to trap heat. This lack of an atmospheric blanket creates a world of shocking extremes. If you land on the side facing the sun, the ground temperature rockets up to a scorching 427 degrees Celsius, 801 degrees Fahrenheit. That's hot enough to melt lead. On the other hand, if you find yourself on the night side, the temperature plummets to a bone-shattering minus 180 degrees Celsius, or minus 292 degrees Fahrenheit. You either burn or you freeze. There is very little middle ground on this tiny, barren rock. Let's say you step onto the sunny side. Even in the most advanced spacesuit, you wouldn't last long. The immediate danger is the sun's radiation, which would bombard you with deadly particles, damaging your DNA in seconds without a suit. With a suit, the heat is the killer. Within 5 minutes your body would begin to overheat, a condition called hyperthermia. Your suit's cooling systems would be overwhelmed. After about 10 minutes, your core body temperature would climb to a fatal 42 degrees Celsius, 108 degrees Fahrenheit, leading to delirium, organ failure, and unconsciousness. Your final moments would be a hot, confused blur. This is a quick and brutal end. Now, what if you tried the night side? Here the problem is the intense, deep cold. The lack of air means heat isn't conducted away from you quickly, but it will radiate away into space. Hypothermia would be a slower, more creeping death. After about 10 minutes in a compromised suit, your muscles would stiffen, and confusion would set in as your body temperature drops. You would lose the ability to move or think clearly. It might take up to an hour for you to finally freeze to death. It's a longer demise, but no less certain. Mercury offers a terrible choice, a quick bake or a slow freeze. The most uniquely deadly feature of Mercury is its extreme temperature swing. No other planet in our solar system has such a massive difference between its day and night temperatures, a swing of over 600 degrees Celsius or 1100 degrees Fahrenheit. This is because it rotates so slowly and has no atmosphere to distribute the sun's energy. You could theoretically stand in a spot on the Terminator, the line between day and night, and have one foot incinerated while the other one freezes solid. Survival here is a matter of picking your poison. Given the options, it's a grim starting point for our tour. Survival rating, 2 out of 10 on the day side, 3 out of 10 on the night side. Next up is Venus, often called Earth's sister planet because of its similar size and mass. But if Venus is our sister, she is the evil one. Landing on Venus would be like stepping into a planetary-sized pressure cooker from hell. The first thing that would kill you is the atmospheric pressure. On the surface of Venus, the pressure is over 92 times greater than what you feel on Earth. This is equivalent to being nearly a kilometer, about 3,000 feet, deep in the ocean. Your spacesuit and your body inside it would be crushed into a pulp in less than a second. It would be like a soda can being stomped on by an elephant. If, by some miracle, you could withstand the pressure, the heat would get you next. Venus has a runaway greenhouse effect thanks to its thick atmosphere made almost entirely of carbon dioxide. This traps the sun's heat, making the surface a uniform 465 degrees Celsius, 869 degrees Fahrenheit. This is even hotter than Mercury's sunny side, and the heat is everywhere, day and night. It's hot enough to melt lead and zinc. In this infernal oven, your body would cook in minutes. You would experience rapid heat exhaustion, followed by loss of consciousness, brain damage, and cardiac arrest. You would be dead in under 10 minutes from the heat alone. But Venus isn't done with you yet. Even if you could survive the pressure and the heat, the air itself is deadly. The atmosphere is 96.5% carbon dioxide, with clouds made not of water but of sulfuric acid. One single breath of the Venusian air would be instantly fatal, as the carbon dioxide would suffocate you and the acid would sear your lungs. The sulfuric acid rain, while it evaporates before hitting the ground due to the intense heat, would corrode your spacesuit in moments, exposing you to all the other horrors this planet has to offer. It's a multi-layered death trap with no escape. The most uniquely deadly feature of Venus is its crushing, superheated atmosphere. It's the combination of extreme pressure and extreme temperature that makes it so uniquely terrifying. While other planets might be cold or have no air, Venus actively tries to squash you, cook you, and poison you all at the same time. The sheer violence of the environment is unmatched among the rocky planets. You would not last a single second. Forget minutes, your existence would be over before your brain could even process the information. Survival rating 1 out of 10. It is, without a doubt, one of the most hostile places in the solar system. After the instant death of Venus, Mars might seem like a welcome relief. It's the planet we dream of colonizing, the star of countless science fiction stories. But don't be fooled by its popularity. The red planet is still incredibly dangerous. Mars has a very thin atmosphere, only about 0.6% the pressure of Earth's. While this isn't the instant crush scenario of Venus, it's still a near vacuum. If you stepped onto the Martian surface without a suit, the low pressure would cause a gruesome phenomenon called ebullition. The nitrogen dissolved in your bodily fluids would bubble out, like the fizz in a soda bottle when you open it. This process would be horrific. Your skin would swell up to twice its normal size, puffing you up like a balloon, though your skin is strong enough to keep you from actually popping. You wouldn't die instantly, however. You'd remain conscious for a few precious seconds before the lack of oxygen knocked you out. The boiling of your blood and other fluids would cause massive tissue damage. Without any external pressure to hold you together and with no air to breathe, you would be dead from a combination of suffocation and decompression in about 1 to 2 minutes. It's a strange and terrifying way to go. Beyond the low pressure, Mars has other tricks up its sleeve. The temperature can drop to a frigid -125 degrees Celsius or -195 degrees Fahrenheit, especially at the poles. While not as extreme as Mercury's night side, it's more than cold enough to freeze you solid over time. But perhaps the most iconic danger is the dust. Mars is famous for its planet-spanning dust storms which can last for weeks. This dust is incredibly fine, like talcum powder, and it gets everywhere. A major storm could clog the filters of your life support system or cover your solar panels, leading to a slow death from suffocation or power loss. The most uniquely deadly feature of Mars is the deceptively lethal combination of its thin air and fine dust. The low pressure creates the immediate, bizarre threat of ebullition, something you don't really see on other planets in the same way. But it's the insidious, creeping danger of the dust that makes long-term survival so challenging. It's not an instant killer but a persistent one that wears down equipment and threatens life support systems over time. Mars doesn't kill you with overwhelming force like Venus, but with a cold, quiet, and dusty embrace. Survival rating, 4 out of 10. You might last a minute or two, which is an eternity compared to Venus. Leaving the rocky inner planets behind, we now arrive at Jupiter, the king of the gas giants. There is no solid surface to stand on here. Jupiter is, well, a colossal ball of hydrogen and helium. Landing on Jupiter means, basically, falling into it. Your journey would begin with a plunge into its upper atmosphere. A chaotic realm of extreme turbulence and honestly unimaginable storms. The winds here can reach speeds of over 360 kilometers per hour, tossing your spaceship around like a toy. This isn't just a storm, it's a planet-wide tempest that never, ever stops. You would be at the mercy of forces beyond comprehension. As you fall deeper, you encounter another of Jupiter's terrifying features, its lightning. These are not your average terrestrial thunderstorms. Jupiter's lightning bolts can be hundreds of times more powerful than anything on Earth, carrying enough energy to power an entire city for a month. A single strike would be more than enough to fry your ship's electrical systems, instantly disabling life support, navigation, and temperature control. You would be trapped in a dead capsule, tumbling through an endless storm, just waiting for the inevitable as the pressure and temperature begin to climb rapidly. The deeper you plunge, the worse it gets. The atmospheric pressure increases at an astonishing rate. Soon, the pressure would become so immense that it would compress the hydrogen in the atmosphere into a liquid. Your ship, if it hadn't been ripped apart by the winds or zapped by lightning, would be crushed flat by the unbelievable weight of the air above it. This would happen long before you reached any theoretical core. Your death would be a result of the ship's catastrophic failure under the strain of the planet's immense gravity and atmospheric density. The most uniquely deadly feature of Jupiter is its sheer, overwhelming scale and violence. It's not one thing that kills you, but everything, all at once. The planet's immense gravity pulls you in, its supersonic winds tear you apart, its mega lightning fries your electronics, and its crushing pressure finishes the job. There is no part of the journey into Jupiter that is survivable. Your ship would be destroyed and your body disintegrated within minutes of entering the upper atmosphere. The king of planets is also the king of violent, multifaceted deaths. Survival rating 3 out of 10. Our next stop is Saturn, the jewel of the solar system, famous for its magnificent rings. These rings, as beautiful as they are from a distance, are your first and most immediate problem. They are not solid structures but are made of countless chunks of ice and rock, ranging in size from tiny dust grains to massive boulders as big as a house. And they are moving at incredible speeds, up to 70,000 kilometers per hour. Approaching Saturn is like flying through a cosmic minefield, or honestly a high-speed blender made of ice. One wrong move, one collision with a fist-sized piece of ice, and your ship would be shredded into confetti. Let's imagine you somehow navigate this treacherous debris field and make it into Saturn's atmosphere. Like Jupiter, Saturn is a gas giant with no solid surface. You would begin a long fall into its hydrogen and helium clouds. The winds on Saturn are even faster and more extreme than on Jupiter, reaching speeds of up to 1,800 kilometers per hour. These are some of the fastest winds in the solar system. The sheer force of this wind would subject your ship to incredible stress, likely tearing it apart piece by piece as you descend into the golden, hazy atmosphere. As you fall deeper into the planet, the pressure and temperature would increase, just as they did on Jupiter. The hydrogen gas would compress under the immense pressure, eventually becoming a liquid. The forces acting on your vessel would be extraordinary. Any part of the ship that survived the wind and the rings would be systematically crushed into nothing. Your end would come from the complete structural failure of your spacecraft, squeezed out of existence by a planet that is mostly empty space, but possesses unimaginable power in its atmospheric depths. You would be gone in minutes. The most uniquely deadly feature of Saturn is undoubtedly its rings. While the planet's interior is just as lethal as Jupiter's, the rings present a unique and spectacular barrier to entry. They are a beautiful, shimmering death trap that would likely destroy you before you even got the chance to experience the horrors of the planet itself. It's death by a billion tiny, high-velocity cuts. The sheer kinetic energy of the ring particles makes any approach a suicidal endeavor. It's like trying to fly a biplane through a citywide hailstorm where the hail is moving faster than a bullet. Survival rating, 2 out of 10. We now venture further out to the ice giants, starting with Uranus. This planet is a strange, tilted world, spinning on its side. It also holds the record for the coldest atmosphere in the solar system, with temperatures dropping to a mind-numbing -224 degrees Celsius. This extreme cold would make any material, including the hull of your spaceship or spacesuit, incredibly brittle and prone to shattering. The cold is the first and most pervasive threat. A tiny crack in your suit would be a death sentence, as the freezing temperatures would kill you in minutes. The atmosphere of Uranus is mostly hydrogen and helium, but it also contains about 2% methane. Methane is not just a simple gas you can't breathe, it's toxic. If your suit were to be breached, perhaps by the cold making it brittle or by high-speed particles in the atmosphere, the methane would be fatal. You would suffocate from the lack of oxygen while being poisoned at the same time. The winds on Uranus are also fierce, reaching speeds of 900 kilometers per hour, which could easily cause the kind of damage that leads to a fatal atmospheric leak. If you somehow survived the initial plunge and continued to fall deeper into Uranus, something truly bizarre would happen. About 10,000 kilometers down, the pressure and temperature become so intense that they could break down the methane molecules, releasing the carbon atoms. The immense pressure would then squeeze these carbon atoms together, creating a rain of solid diamonds. While it sounds poetic, this process would also apply to the carbon atoms in your own body. You would be crushed and crystallized, your organic form turned into a shower of tiny, imperfect diamonds in the deep, dark, slushy interior of an ice giant. The most uniquely deadly feature of Uranus is its potential to turn you into a diamond. While death by cold, poison, or pressure is common on our tour, death by crystallization is unique to the ice giants. The thought of your body's elemental components being violently reconfigured into gemstones under unimaginable pressure is a uniquely terrifying and strangely beautiful end. It is a slow, crushing process deep within the planet's core, a final transformation in one of the solar system's most mysterious worlds. Death by diamond rain is a fate reserved for the truly unlucky cosmic explorer. Survival rating, 1 out of 10. Our final planetary stop takes us to the edge of the known solar system, to the dwarf planet Pluto. Pluto is a small, icy world, smaller than Earth's moon, dwelling in the Kuiper Belt. Its defining characteristic is the cold. Being so far from the sun, the surface temperature on Pluto hovers around a soul-crushing -239 degrees Celsius. This is a cold so profound that nitrogen, a gas on Earth, freezes solid and forms glaciers on Pluto's surface. It is a world locked in a deep, permanent freeze, a silent, lonely outpost at the frontier of our solar system. Survival on Pluto is entirely a battle against this absolute cold. A FD&W stepping onto its surface would be an immediate peril if their suit's heating system had even a minor malfunction. The cold is so extreme that it would leach heat from your body with terrifying efficiency. Within 30 seconds of exposure, frostbite would begin to ravage any exposed skin. In another 30 seconds, your bodily fluids would start to freeze, your blood would turn to slush, and your cells would crystallize and die. It's a rapid, brutal process. After just 2 minutes in the Plutonian cold, your body's core temperature would drop below 30 degrees Celsius, leading to severe hypothermia and loss of consciousness. You would simply drift off into a frozen sleep from which you would never awaken. After 3 minutes, your body would be frozen solid. Your organs would have completely failed, and your tissues would be as brittle as glass. You would become a permanent frozen statue on the surface of a distant world, a silent monument to the unforgiving nature of deep space. The most uniquely deadly feature of Pluto is its profound and inescapable cold. While other planets are cold, Pluto's cold is different. It's a deep, ancient cold, far from the warmth of any star. There is no dayside to offer a brief respite, no thick atmosphere to trap any residual heat. It is just pure, unrelenting, absolute zero's next-door neighbor. The danger is simple and absolute. If your technology fails for even a moment, you will freeze solid in minutes. It's a quiet, lonely, and incredibly quick death on the solar system's desolate doorstep. Survival rating, 3 out of 10. Our cosmic journey of doom has taken us across the solar system, revealing a spectacular variety of ways to die. We've been scorched, crushed, irradiated, frozen, torn apart by winds, and even turned into diamonds. Each planet offers its own unique brand of lethality, a testament to how special and rare our own life-sustaining Earth truly is. Now, it's time to tally the grim results and determine which planet wins the prize for being the most hostile. and which by a very slim margin, might be considered the easiest to survive if only for a few moments longer. The undisputed champion of deadliness is Venus. With its trifecta of crushing pressure, hellish temperatures, and a poisonous acid-laced atmosphere, it offers the quickest and most certain death. You wouldn't last a single second. Your end would be so instantaneous that it's hard to even imagine. Uranus comes in a close second, with its unique threat of being crystallized into a diamond on top of its extreme cold and toxic air. The gas giants, Jupiter and Saturn, are also incredibly hostile, tearing you apart with winds and pressure before you could even get very far. In the middle of the pack, we have Mercury and Pluto. Both offer death by extreme temperatures, either hot or cold. However, they lack the atmospheric pressure and chemical dangers of the other worlds, making the death slightly less complex, though no less certain. You might last a few minutes depending on your location and the integrity of your suit. These worlds are passively deadly. They will kill you with their environment, but they aren't actively trying to crush and dissolve you in the same way Venus or the gas giants are. They are still horrific places to be stranded. This leaves us with Mars. By a long shot, Mars is the least deadly planet on our list. That is not to say it is safe, it is absolutely not. The thin atmosphere, cold temperatures, and deadly dust storms would still kill you in minutes without protection. However, compared to the instant death on Venus or the violent descent into Jupiter, a 1 to 2 minute survival time seems almost leisurely. It's the only planet on the list where humanity has a realistic, albeit difficult, plan for future colonization. This grand tour of peril reminds us that while the cosmos is beautiful, it is also profoundly indifferent to our existence. For now, there's no place like home.